This is the Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
Welcome, everybody. It is June the 10th, and I think that this week will feel a little bit more familiar for those of you who watched last week or attended with us last week. When we talked about multiplication, we really looked at the nuts and bolts of multiplication, and it was kind of ugly. I'm not going to lie that writing things out horizontally was not necessarily super fun. So this week, I think we're going to look at some things that are more familiar and then talk about how we can hopefully mesh the two things together. But first, we are so excited. So what started as a side conversation several months ago about being able to let people sort of create a custom errata has turned into a beautiful website, and where you can actually go and you see up in the right hand corner, you can download the sheets that you have today, that if you were to go to the bookstore and download the errata sheets, that's what is there. You can download them from this website also. But at the end, when we're finished talking about multiplication, if you would like a live shot of this, we can do that. But what is really, really exciting is that you can come down here and pick. So let's say you have children that are in integers, decimals, and fractions. I can actually see 3 columns and I can see the errata side by side. And then I can pick, hey, I just want to see book 4 today, or the pages, it kind of depends on where there are errors, but you could say, hey, I just want to see what's on chart 1, if there's an error on chart 1, for example. So very exciting. You're going to be able to create your own sort of custom view of the errata. And I think that this is going to help you to feel like it's a little bit easier to interact with, as well as it's going to be updated, hopefully daily. So we may not quite be at the daily point yet, but it's going to be a lot more frequent than it is updated on the bookstore website. So you can actually come here, and within the next few weeks, if you submit an errata this morning and that gets processed, now it doesn't always get processed the same day because Lee has to approve everything. But once those changes are approved and made and entered into the errata system, this will be updated the very next day. So we're going to have a lot faster turnaround on getting that errata published for you. So we're very excited. You guys are the first really to hear about this formally. And again, we can show you a little live preview at the end of today. Are there any questions about this before we start talking about multiplication? All right. So just to review what we talked about last week, we remembered that we talk about factors and products when we're talking about multiplication, that I can have really as many factors as I want, but your minimum number of factors would be 2. And the result of multiplication is called the product. Now we could write, right? We could actually, like we do for the power, I'm just going to turn my laser pointer on here, right? If I sat here and I said, wrote factor times factor, I could say that's the product, right? If I wrote 2 times 3, I could refer to that as the product of 2 and 3 because I'm meaning the entire expression, as well as the number 6. We talked last week about how when we have 2 numbers, there's 2 pieces of information we get from each number. We get the magnitude, the scale, and then we also get that it's either going to preserve direction or reverse direction. And then we get a length. And again, we're going to be in the positive direction or the negative direction. So that's the positive and negative. We see that multiplication is equivalent to repeated addition. So that's the the connection between skip counting, that skip counting allows us to get to multiplication. It's commutative, it's associative, and all of our multiplication is based on the distributive law. We usually hide it a little bit more for our digits, but we could actually write it out to see where the repeated addition comes in. All right. Any questions from last week? All right. So moving on to our next slide, I thought it would be fun to just take a minute and think about the history of multiplication, which is the Egyptian model. So this is how the Egyptians historically did multiplication and division. I probably won't talk about it as much with division, but it also has been used more recently for computers because it can be a faster way of actually computing because it doesn't necessarily rely on understanding place value. So it's a little bit of a shortcut in some ways because we're not, the place value obviously is still a part of what we're doing, but we're not multiplying with place value. We're just doubling, this idea of doubling. So when we want to do this, right, if we were to want to do this, let's say we're multiplying 27 and 19. In my left-hand column, whichever number I pick as my first number, I start with 1, and then I double that until I get to a number, and that should say double, not bubble. Sorry about that. So that when the next doubling would be more than 27, right? So if I was to double that again, I'd get 32. So I stop at 16. I then go to my second column and I double my number. So I start with 19 and I double it the same number of times that I doubled 1 in my left-hand column. Then I come back and I say, okay, 27 is 1 plus 2 plus 8 plus 16. So I identify the numbers that sum to 27. And whatever the corresponding numbers are on the right, I'm going to sum those. So it would be 19, 38, 152, 304. And when I sum those up, that becomes the product of 27 and 19, or my two numbers. So they have evidence that this was actually how the Egyptians did use to multiply. And it may be something as if you have students who are interested in history or just having fun, teaching this to them is not going to be a replacement for, I don't think it would be a great replacement for our modern way of multiplying, but it would be a fun thing that you could do as a family, especially if you're looking at any other aspects of Egypt. We're going into cycle 3. So think a year from now when we're going into cycle 1 and thinking about all things Egyptian, this would be a really fun thing to add over the summer to think about multiplying like an Egyptian.
So, Kirsty, will there always be, like when you looked at the first column and you picked out the digits that equal 27, will there always be, it will always come, like, you understand what my question is,
Yeah.
that I can't
So,
ask?
yeah, well, let's pick. So pick a number.
Like, do you mean like 31?
Sure.
Okay.
So let's look at 31, right? And so if I said I was going to do 31, it would be the same, right? I would stop at 16. And so what would sum to 31?
16.
Why are we skipping 4?
So we skipped 4 because we were looking for which of those numbers sum to 27. So 16 plus 8 plus 2 plus 1 would have been 27.
Got
So
it.
now we're going to do this for 31.
So we will use the 4 this time.
And yes, right? So 16 plus 8 is 24. What do I need 7 more.
So 4, 2, and 1. You need, right?
Yep. I'm going to use all of them this time, right?
Okay, so that'll always, I mean, we've done two, so, but I'll believe you if you say that'll
Well,
always.
so what would happen if, so it all comes from binary, right? These are all powers of two.
Okay,
So
yeah.
basically what we're saying here is that if I was to write 27 in base 2, it would be, right, so 27 would be in base 10 would be 11011 in base 2.
Oh my goodness. So it was like on, off, on. And
Yeah.
the, oh,
And let's say we looked at 32, right? Well, if I doubled it one more time to 32,
you'd have
right?
1 0 0 0 0 0.
Yep.
Oh
And
my,
so we know that we can use those binary to count, and that's all we're doing here. That's all right? So it's this hidden binary system within this Egyptian model of counting.
It looks
that's
like a magic trick to me.
It does feel like a magic trick, doesn't it?
it does, yes.
That's why I think this is something that would be a fun thing to do with your kids, right? And especially to revisit it, because you could do it with younger students and just practice doubling things, right? You can practice doubling. And then with your older students, making that connection to base 2. And then, right, because that's a really great question. Can I count every number with doubling? Well, when we go, oh, well, it's just base 2, I can count every number in base 2. Yeah, this must actually work, right? And so I think that there's a lot you could explore here with your students and really have fun with this, because it's not your traditional mathematics, but you can really explore this and have some fun, um, and learn, right? Because you're looking for the patterns and making these connections. Any other questions? Okay, so last week we really were working horizontally, and it's probably the clearest expression of the distributive property. Now, here I did not write out all the steps like I did last week, but I could say, okay, I have my 12 times my 40 and my 12 times my 5. Then I could write my 12 as 10 and 2. And so I'm sort of skipping some of those steps to show you when we work horizontally, right? This is sort of what it looks like. Now, it's not very common that we do this with bigger numbers, right? If we were multiplying digits, I think then we would say that it's fairly common to write 6 times 5 equals 30. 12 times 45, it gets a lot less common to write that horizontally. And I would argue that that's because it's just a lot harder to keep track of the details, right? We kind of start to become overwhelmed. Now, it's more common when we do it algebraically. And I think that the reason why is because the distributive property and the expansions of our numbers is somewhat hidden when we're just looking at numbers, right? Traditionally, it's been hidden. With algebra, the only way I can multiply two binomials is with the distributive property. And so it is, in this case, I distributed backwards. So I distributed 2x plus 20 over 9x and 2x plus 20 over 27. And then, right, and so this is why I think it's more common for us to see it when we are looking at algebraic expressions, because we can draw those arrows and see that what we're doing is the distributive property. Now, as we look at different arrangements, you might go, oh, wait, this other arrangement is really much easier for algebra as well. But I wanted to start here because this is really the connection to last week, right? When we think of things that are horizontal, this is really our connection to last week. Any questions? All right. So we do not really teach this in the math map because Lee didn't want to just always jump to shortcuts. So we don't really refer to this. But a lot of our parents probably remember the FOIL shortcut. This is only for binomials. And you're going to see here that I'm showing that I can consider my 2-digit numbers as binomials because I could write each of those as 10 plus 2 and 40 plus 5. And then it's the same thing, right? That the FOIL, first, outside, inside, last, all it is doing is giving us a mnemonic to help us remember, right? That or keep track of our distribution. So if we think about this, what I'm really saying is I'm taking my first and distributing it over the 2x and the 20. So that's my first and my outside. Then if I took my 27 and distributed that over the 2x and the 20, now I have all of my distributions taken care of, right? I have 9x and 2x, I have 27 and 2x, 9x and 20, 27 and 20. And so that's where I get my inside terms and my last terms. So there's no magic. FOIL is just a mnemonic to say, here's how you can make sure you got all of your distributions done. Okay. And it works, as I said, it works for 2-digit numbers, right? That I can take my 10 and distribute it over my 4 and my 5, and my 2 over my 40 and my 5, and I end up with the same result. I don't know that I would do it that way, but I wanted to point out that all of the things, I guess my goal for you as parents is that you see that all of this multiplication is the same. We're just using different numbers, different literals, but it's all coming from the same basic idea. So again, only for binomials, and it's all it is a mnemonic. It's not anything special. It's just a mnemonic as a shortcut to make sure that we're hitting all of our distributions. Any questions on FOIL? Okay.
Hey, sorry. I was going to say this
Nope.
isn't a question, but if somebody's just looking at that slide, they might think you're subtracting instead. I think your first outside, it's, like, so those are not subtraction signs.
They are not subtraction signs. They were just, I guess I could have used colons. Maybe that would have been, then we would have thought they were ratios.
Or just leave them out, just,
Yes.
yeah.
Sorry. Sorry if I made it. This slide, and I'm just going to put here that this is what we oftentimes think of as the algorithm. So if you were to Google all the different ways to multiply and they talk about the algorithm, this is really what they're talking about. And I think for most of our parents, this is what we were taught. When the uproar about Common Core came out, this is what they sort of moved away from. And parents went, well, what happened to the way I multiplied, right? This is it. And there's nothing wrong with it because it is efficient, right? But it really helps us not to see the distributive property and place value, right? And especially the way that it's taught, we don't use that language. So I really wanted to take a minute here and work through this so we can see how what we're doing is distributing, right? That's all we're doing all the time is distributing, and making trades and doing place value things. But it just gets hidden because we're in this very compact arrangement. So if we think about, all right, what we were doing before, and I maybe thinking about that FOIL example is one of the best, right? Because we saw how I had to pair each of my numbers when I had a 2-digit number. I need to make sure that I multiply my 20, right? And I'm just going to, or 2 10s by 5 and my 7 by 5. Then I need to make sure I multiply my 110 and my 210 and my 110 and my 7. Right? So that's my goal, is to make sure that I get all of those matches done. And so the algorithm says go in this order and you'll make sure you get all of your matches. So in this case, if I said 5 times 7, we all know that is 35, right? And what do? We write the 5, and then what do we do?
We
Put the 3 10s in the tens column.
Right, right. And what word did we all learn? We carry, right? So all we're doing is saying that 35 is 3 10s and 5 1s. So I can write my 3 10s in my tens column and my 5s in my 5s column. Right? That's all we're doing, is we're making that conversion from 1s to 10s. But we didn't necessarily always talk about that when we learned this. Now, our teachers may have. I'm just suggesting that most of us just learned the algorithm and didn't remember anything that they taught us about why this worked. Because if the emphasis was on getting this correct on the test, right, you would say 5 carry my 3 without necessarily understanding that that's what happened. So that's why I'm talking through it. Next, I would have my 5 times my 2 10s. So if I have 5 times 2 10s, I now have 10 10s plus 3 10s is 13 10s, right? So again, I would say I have 3 10s and 100. I would take my 10 10s and convert them to 100. And I can put that there, right? Because there's nothing there. So I bring that down because it's 1 plus 0. Now, what do we do next?
You have to put in that 0.
Right? Why do we put in the 0?
I don't
That's
think
what I don't
anybody ever
remember.
thought about it, but it's because we're multiplying by
Tens.
tens. We have
Yes. That's it, right? This really is 110. So if I multiply 7 by 10, what do I get?
70.
70. That's why that 0 goes there. Right? Because I'm really multiplying by 10, not by 1. But then what do we say? Well, 1 times 7 is 7. And notice, because of the way we typically talk about it, we lose the sense of place value. And we just remembered you have to fill in the 0. That's why, because I'm multiplying by 10. And so then I have my 70. And then if I had 110 times 2 10s, I would see that what do I end up with? 200. So that's going to go in my hundreds column. Right. And now I can add. And so that's my 10 and 4. Right, 405. So notice, right, is this nice and compact? Yes. Does it help us keep track of our work? Yes. Does it hide all of that place value and distributive property? I think it does. And so at the end, we're going to talk about, right, sort of what we're going to use, right? When do we use this? And so I think it's going to be up to each family, but we're going to talk about that at the end. So that's with numbers, right? I'm doing that. If I'm looking at this algebraically, right, it's the same thing. I need to distribute my 20 over my 27 and over my 9x. Now, here's sort of side work, right? 27 times 20. And I'm just going to go ahead and fill that in. It's 540. My 20 times my 9x is 18x. This is where we probably would think of our students
Be
right,
180x. Sorry.
thank you.
180x.
Right. This is where we want our students to be able to either calculate or do this on their own, right, on the side, so that we're not writing out all of this. That's why arithmetic matters so much before you get to algebra, so that you can start doing these computations a little bit more quickly. But then I'm going to distribute my 2x over my 27 and my 9. So 27 times 2 is 54x. I'm going to line up my like terms, so my x's with my x. Then 2x times 9x is 18x squared. Right. Notice I can put my 0 in here because when I multiply by 2x, I don't have any ones. I don't have a constant term or 0th powers of x terms. And then the same idea, I'm going to add my like terms. So 540, 244x, and 18x squared.
34. Sorry.
Thank you. Oh, I'm so glad there's some people that are better at arithmetic than me on here. All right. I think for algebra, to me, this is probably my preferred method because it helps me line up my like terms. It helps me do my distribution. This is probably my preferred way of multiplying. My preferred way of multiplying for numbers is probably my calculator, but don't tell Lee I said that. But I know how, right? That is the key, is that we want our students to know what they're doing and how to do it before we start saying, yes, use a calculator. So questions on this vertical arrangement. Again, it's compact. It helps us to align place value, but it does obscure the distributive property and place value considerations. Okay. So just for numbers, I don't think I would ever use this for anything other than numbers. It's very similar to vertical multiplication. We line it up the same way, but the idea here shows a little bit more of the place value that we're working with. It can be worked from left to right or right to left. What you do need to make sure that you're doing is being consistent. So if we were to work left to right, again, I'm going to distribute over both of my digits, and I would see that I have 10 times 20, which is 200. Then I would have 10 times 7, which is 70. Now I'm going to take my 5 and distribute my 5. 5 times 20 is 100. 5 times 7 is 35. And now I'm going to sum, and I get the same answer. What this does is it expands a little bit. So you see a little bit more of the place value. You actually track each one of your partial products, right? That's what we call those, are the partial products. Instead of it being hidden the way that we did it with the, right, having to annex the 0 and so forth, here it all lines up and we see it completely. You could work this right to left. You can work it left to right, right? It doesn't really matter because we would have just gone in the opposite order. We would have had 35 plus 100 plus 70 plus 200. Questions about partial products? All right. So the next arrangement of multiplication is oftentimes either called the box or the open area. This is a clearer way to show place value and distribution. Typically, when you use this, you write out your tens, right? So instead of just using the digits, we actually write this as 20 and 10. And then what do we know that when we have a table, right, we have 20 times 10, 5 times 20, 7 times 10, and 7 times 5. We see all of those partial products there. And then what do we have to do? We have to sum them. And so we could either sum this way and get 300 plus 105 equals 405. right? You could have summed this way, 270 plus 1, hang on, come back. Okay. Oh, there we go. All right. 10. 135. And if I was to sum those, I would get 405. Right. Again, that's called the box or the open area. This is commonly what they were doing with Common Core, because they were trying to help students to see what was going on behind the multiplication. But if you don't understand place value, then you don't necessarily see where the 20 and the 7 and the 10 and the 5 came from. If you don't recognize the distributive property, right, seeing that this is just laying it out as a way to get the distributive property, it feels like more work. And I think that that's where the disconnect was for a lot of people when they looked at Common Core, because probably even the teachers didn't necessarily see that connection. But this can be helpful for your students, right, to be able to see how each number gets matched and where that place value comes into play. This is, again, another good way to keep track of what you're doing with algebraic expressions. So if I have 9x plus 27 times 2x plus 20, again, each of these boxes becomes my partial sum. 9x, yeah, that should be 18. 9x times 2x would be 18x squared. 27 times 2x would be 54x, and so forth. And again, now I can come through and I can say, I'm going to sum my partial products and I get my 18x squared. I'm going to add 180 and 54 to get 234x plus 540. Now, very closely related to this, but sort of done a little bit differently, is the idea of the lattice arrangement. And I've written it sort of the opposite way to the box, because you sort of need to be able to work your lattices top left to bottom, top right to bottom left. So here we still see that I can show my place value. Now, some places you'll see they don't always show the place value. They might just write 2, 7, 10, and 5, and then you keep track of it. I think it's easier for students if you do write out the 20, the 7, the 10, and the 5, so that it helps you to keep track of the place value. So if you look at just the part there that's filled in, it looks just like our box or open area method, but with our times 15 on the right-hand side. But what we can see here is if we were to go here, these are my 1s, these are my 10s, these are my 100s. And so I can actually sum, and I say, okay, I've got 35, I have 170, right? And I have 200. Now I still have to be able to make my trades or my conversions, right, between my 170 to make this, which is, right, 70 for my 10s, and that would make this 300. And then I still see that I get 405 when I add all of those together. And this, it doesn't matter how many digits, they're always going to be common digits or common units on the diagonal. So we see it, I think, with the algebra a little bit more. So here we see that I have my 0th power, my 1s or constants, which is 540. Here, this is my first power of x. And so there's my 234x. And here's my x squareds. And so I get my 18x squared. And then I can sum those and I get my result. So again, very, very similar, but you kind of have to write it this way because those diagonals, the way that they go, you need that room to the left. And again, if you had a lot of digits or two polynomials with a lot of terms, I think that's where you would notice that this would really be helpful in keeping track of where my common units are. So that's called the lattice arrangement. All right, I've got one more for you, and that is the Japanese arrangement. Some people call it the Chinese arrangement. I've also seen it called the lines. And there's all kinds of different ways that people draw this. It really is just for your numerals. But I'm gonna show you. So let's start with 27. I would draw 2 lines for 20, and then I would leave a space, and I would draw 7 lines. Then I kind of go backwards. And I guess it doesn't really matter. You just have to keep track of all of the crosses, right? So this is our distributive property now. Is let's say I did 15, and I'll just do it this way, right? So now there's my 1 distributed over my 2 and my 7, and here's my 5 distributed. You do have to keep track of your place value. So I do want to make sure I remember that these are my 10s, these are my 1s, but then I can count, and I have, right, 200. Right, so those are my hundreds. These are going to be my 10s, and then these are going to be my 1s. So I can, again, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I'm going to add my 17 10s. And then if I was to count up, right, and I'm just going to use my 5 times 7 because I can do that instead of counting. There's my 35, and there's my product of 405. Notice how all of these methods are all just different arrangements to make sure that you hit all of your different distribution goals. But if you don't know that that's the underlying principle, they can feel very, very different. And they can almost feel sort of magical, right? So the number, I've seen this pop up, right? Oh, the magic Japanese trick for multiplication. It's not really, right? It's just visualizing, right, the distribution. That's all we're doing is saying, let's make sure we look and distribute our numbers so that all of our intermediate or partial products are found. Now, before we talk about what to do, this is what, if you're wanting to practice this summer or at whatever time you're watching this, I would suggest that you use dice or cards and create your random numbers. And then with those same numbers, use all of the different arrangements. Help your students to see that the arrangement does not matter. You're always going to get the same product. Then help them look and see, right? Draw your arrows to see how each of these arrangements is using the distributive property. Right. Again, that yielding the same products, I think, is important for our students because it can feel like they're doing something very, very differently each time. And the more experience they have going, it doesn't matter, I always get the same answer, gives them some consistency and constancy, and then helps them to be confident that whichever method clicks for them is going to be trustworthy. And so again, the first time through, I would say, which one of these works for you, and let them use that. Then maybe come back and push them and say, okay, well, what's another method that might work, right? So that they gain that comfort or with doing it in different ways. And it might be that some students seeing it written as area really makes it clear to them. Some of your students that do not like to show lots of work, they might be like, no, I see how this vertical arrangement, this algorithm works, and I want to do that. And so I would work with your student, not against your student. And then I just wanted to touch on this, right? Do we use the algorithm or do we aim for understanding? The way that I was taught, and I'm not sure right where we all fall on the Common Core, because I realize I'm getting old, and we may have all had different educational experiences. But for those of you who are of my vintage that learned using the algorithm, right, we may not have had the emphasis on understanding where that came from. For people who have come through more of the Common Core or emphasis on that understanding, they were maybe never introduced to the algorithm, and they feel like multiplication takes a long time, but maybe they have a better understanding of it. So I would say that there's a mix of both. You could start with the algorithm, right? And here's the beauty of doing multiplication year after year after year with the math map, right? Is you can start with the algorithm. If that's where you are confident, or if that's what's clicking for your student, start there. And then practice, practice, practice. But as you're practicing, as they become more fluent in using the algorithm, slow them down and say, okay, well, show me where is the distributive property in this? Show me where does place value fit into this, right? So let them gain familiarity, let them gain confidence with the algorithm, but then pull them back and go, okay, now I want you to tell me why this works. For some families, that might be the familiar and the comfortable, and that's okay. For other families, you might go, no, we're going to really emphasize the distributive property and the place value, and we're going to use these other ways, the lattice or the box. We're going to use these other ways so that we really understand what we're doing when we multiply. But then over time, maybe we start to look for patterns and going, well, do we have to write the box out every time, right? Is there a shortcut? And they may actually discover the algorithm themselves, right? Because it is efficient for when we're doing multiplication that way. So I don't think it needs to be one or the other. I think you can start with where you want to be, with what's familiar to you. Start with what is comfortable for your student. And then, right, we have years of working through multiplication to combine the two. Any questions on all of these different arrangements? Now, nobody else has another arrangement that I didn't, because I really searched, because I was like, I want to try and capture all of them. So if somebody else has one, feel free to share. Babs, did somebody have something from the chat?
No, I was just going to say that this whole discussion has kind of, I don't know, it like re-emphasizes what I was just on an orientation call, and I had a parent, well, she was a tutor, but she was also a parent, and her husband was like, I don't know if we should do the math map. He's on the fence. And I was trying to kind of explain to her what you were saying, that understanding the why is more important, because eventually, right? Maybe not necessarily up front, but because like our kids take all kinds of tests, right? They'll take these standardized tests or whatever, and they're not going to present this problem in the same way that maybe our curriculum did. And I only had experience with Saxon, and so the same thing, like my kids use Saxon, and then they still were like, okay, we got to do SAT classes, because those questions are different than the way they were asked. But if they understand the why behind the question, then it doesn't matter how the question is presented. And so I just feel like this whole conversation of all these different ways just helps us see the value in understanding the why, not just being a good calculator or knowing one way and that's the, being an expert at that.
Thanks. Any other questions? All right, so just a reminder, we are here for you, and here are our weeks coming up. Because the 4th of July lands on a weekend, I'm not planning to take Wednesday off, so we're going to take 3 weeks to talk about division. So we did 2 weeks with multiplication. We're going to look at 3 weeks with division, and then we're going to take a couple of weeks where we really dive into fractions. And so we've looked a little bit at fractions. Notice with our multiplication, I didn't go there. I didn't talk about multiplying fractions. We're going to take a couple of weeks and really just look at what does it mean when we're working with our fractions. Because again, all right, going back to understanding fractions, I think is going to be helpful. That's probably where, if I had to guess, when I talk to people about arithmetic, 90% the issue is with fractions. And so we're going to spend a couple of weeks just talking about calculation with fractions. So we'll kind of pull together all these things we've been talking about and take a deep dive into fractions. But the next 3 weeks, division, right? The undoing is usually harder than the doing. So that's why we're going to look at 3 weeks of division and 2 weeks of multiplication. Just like I can make a cake, but taking it apart is pretty much impossible. All right, although God does it right in our bodies, he takes all that food and pulls it apart in ways that we never could. So then we had, before I open it up to your questions, Babs was sort of giving a little bit of a preview of this. We've had some questions about testing, and specifically the fact that because the math map is different, it doesn't necessarily always align with tests that people are doing. And their students sometimes see great gains in their tests and sometimes feel like they've regressed in their tests. And I wanted to sort of address this testing question specifically. First, if you haven't heard my soapbox, right, I really want to encourage you to set your own goals for your homeschool. Don't let the world tell you what matters about your homeschool math education. It doesn't have to be that you're educating to get into college. It doesn't have to be that you're educating for a scholarship or a test grade or, right, whatever reason. I remember being in high school and we had the poster up on the wall in the classroom, right? When am I ever going to use this? And it was like, well, if you watch TV, there's all kinds of math in that. I don't need math. I can just watch my TV, right? And so I really want to encourage you. What is your goal for your homeschool when it comes to math education? I recently did a study, and so I'm not going to go too far down the rabbit hole, but one of the things that I heard was somebody, more than one person say, right, we homeschooled because we wanted family unity, or we homeschooled because I wanted to do things differently to what I experienced. And then what happens? Well, we want family unity, but we're using a computer-based math, and so my kids are all sitting in front of a different computer. Or I wanted something different from me, but I ended up choosing the thing that was familiar, and so I got the same results. And I'm not bashing anybody, right? But what I want to say is that you have the freedom to set the goals for math education in your home. And I really encourage you to stop and think, why are we homeschooling? What is it that we want to get out of math education? You know me, I think we talk about this most weeks, right? To me, really, the only valid reason to study anything is because it's going to teach us more about God. I absolutely firmly believe that there are things that God is going to reveal about himself through mathematics and not anywhere else. So if you choose to not study math, there are things about God that you will never learn this side of eternity. So why should we study math? Because we want to know God. I think that really needs to be our first thing. And I know that everybody's right, everybody's different, so I'm not trying to preach to you, but that's where I've landed on why am I studying math? Because it's going to teach me about God. And then I'm claiming that promise, right? That if I seek first his kingdom of God, he's going to take care of everything else. If I want to discover God through mathematics, I have to learn how to multiply. I have to learn how to find patterns, and I have to be able to maybe solve an algebraic equation, right? The more I want to learn about God, the more math I have to learn. So having that as my goal is going to help me do the rest. Other things that you can consider are your family priorities. What are your students' plans or goals post high school? What are your students' interests? Do you have learning challenges? Right? All of those things can go into what are the goals for math education in your home. I have a dancer, and her whole desire is to dance professionally. So I was not feeling like I needed to necessarily emphasize being a great calculus student. But I did want her to understand geometry. I did want her to have a recognition of the beauty in mathematics, right? So my son, we had different goals, but then we also had goals as a family. So I really just keep encouraging families to really stop and think about what are your goals for homeschooling and then specifically for math education in your homeschool. And it doesn't have to be what the world tells you. Then I know that most of us either are required to test for our states or because of some kind of entrance, right? If you're testing, take that and consider that separately. Don't let that test that some person you don't know, who doesn't know your students, who doesn't know your homeschool, who has different goals to you, and there's a whole conversation we can have about why we have tests and why they were never designed for individual achievement measurement. Consider the test that you're using. And then what skills are being emphasized? Primarily, they're using calculations to test your students because it's easy. It is easy to test how well your student can calculate. It's a right, wrong, and it's easy, right? It's a cheap way to assess students. So look at the test that you're using and go, what skills do they need for this test or level? And then incorporate that practice into what you're doing with the math map. If you know that for this particular test, they're going to be doing 3-digit multiplication, practice 3-digit multiplication during the year, right? Create those exercises and practice that as test prep, right? There's nothing wrong with teaching to a test if the test is not the be all and end all of your homeschool day. If you are setting your goals and saying, we're right, this is what I want to accomplish, and this is what is guiding our homeschool day, I can also teach to a test. If you have the ACT or the SAT coming up, or some other kind of test that you're taking, there's specific test prep available that absolutely makes sense. It's going to make sure that the correct type of calculations are practiced. It's going to give your students experience with the specific kinds of test questions, right, that are going to be asked. It's going to give them different skills on how to work under that time pressure. So there's nothing wrong with teaching to the test if it's a separate secondary process to what you're doing with the rest of your homeschool day, right? You can take some of your time, right, and do that, but don't let that be the driver of everything that you're doing. So anyway, there's my soapbox. I will tell you this also, from my research, the only parents who said that they were highly satisfied with math education in their homes were the parents who said that they had moved from checking the box or going through the curriculum to seeking God in mathematics. Nobody in my study who said that they were right doing it because they had to still was happy with their math education. But everybody who had made that shift to go and I'm looking for God, they were the ones that said, yes, we're happy with things where things are in our math education. So anyway, for what that's worth, I just wanted to share that. So thanks for letting me be on my little soapbox there, but I really hope that that encourages you when it comes to testing, and encourages you that, right, you don't have to let the test drive what you're doing. All right, any questions?
Do you mind telling us your sample size?
I had I think I had 17 interviews that I did. So it's not a huge sample, but for the type of study, that was actually a big sample size for the type of study that I did. And so that's generally considered to be very acceptable
Yeah.
sample size. It's not like a quantitative study where you really want to have more, because it's less about the generalizability, and more about what you learn. So anyway, that's probably more information than you needed. But and you can ask other questions too. Any last questions on multiplication or anything else we've talked about this summer? Or if there's anybody that's, taking a second look at their booklets over the summer, if you have questions from those, we're happy to answer those also.
How did you come up with your different arrangement options that you shared today?
So I knew some of them, actually I'd seen all of them, but I actually went and did some internet research on what are all the different ways that people are teaching multiplication. That box method was really what became, I think, more popular during Common Core, the Common Core rollout, where a lot of people were going, my kids are learning this weird way. That was really what it was, but people didn't know that it was right the same thing. They thought it was something new, when it was all the internet rage to talk about. So that was really, if you go and look online, I would be interested to see if you find another arrangement out there, but I tried to capture all of the ones that were out there that you may have seen in other curricula, or just floating around the internet if you're looking for that.
So I was distracted for just a little bit in between, but so tell me if you've talked about this, but I grew up in Switzerland, and the way we did multiplication was, we put it like the numbers next to each other instead of under each other. Like, so 27 times 15 will be on one line, and then you underline it, and then you kind of distribute it like that. So 7 times 5, 7 times 1, and you write it under it. So just a little bit different.
Yeah, and I like the fact that you're saying I'm still distributing, right? It's just a different arrangement. And so that may be, right. There's an infinite number of arrangements. And so challenge your kids. Go find the one that works for you, that's going to help you make sure that you get all of your distributions done and find all of your partial products to sum. Because that's really all that's happening, right? Is I distribute and I find my partial products and I sum them all together. All right, we have a couple of minutes, so I'm going to stop sharing here, and I'm going to start sharing this page here, and I'm going to go to, all right, can everybody see the math map errata on their screens? Did I share correctly?
Not
No.
yet.
All right.
Also, make sure you type in the math map, because I did not put the in there, and then some crazy stuff kept popping up, like a virus looking thing. So I was like, so make sure you write the math errata dot the math map.
Are you seeing it now?
Looks like it's trying. Oh, nope, it stopped.
Okay.
Not trying anymore.
It is not trying anymore. Okay, let's try one more time.
Looks like it's trying.
Now?
There you go.
There
Yep.
you
All
go.
right. So notice here, so let's say that I have a student who in integers and somebody in fractions. And you can see here that it lines up. And I can see, hey, there's some things that needed to be changed in all of these. Now, this is all my booklets. And so maybe I go, oh, I don't need ex nihilo. I'm in lesson 13. I only want to see that. And now notice there's only 7 things in the integers, right, for lesson 13. It's a little bit easier. And then perhaps here I see, okay, this is the same in both books, right? Here are some things that are a little bit different in each book, but I think this is a lot friendlier and easier to keep track of. If you happen to like the current format, you can click on downloads. And you can click on the particular domain. And of course, it's going to take a minute to load because it's using all my bandwidth for the Zoom call. But you'll see that if I click on that, it's going to look just like, it may be more updated. I will let you know that it may be updated more frequently, but it will look like what I currently get from the bookstore website, right? Where there it is. It's the whole thing all together. So I just wanted to share that. So if you're, we know that it is really frustrating, right? We know the errata is frustrating. We don't want to minimize the frustration that comes from that. So because, right, we're still developing this product. It's going to be a couple of years before we're able to say, yes, we've fixed it all. Because we couldn't fix it faster, we wanted to give you a better errata experience. And so hopefully this does it.
Yeah, this is great. And I feel like it's going to be much better for you all too, because like you have 17 people tell you about the same thing. And this way, if it's in there,
Hopefully.
This is great. Good job.
Yeah. So definitely a big shout out to our IT team because honestly, I went to them and I said, look, what if we had a spreadsheet? Is there a way to host a spreadsheet that people could just filter? And this is what they came back with, which is way more than a spreadsheet, much prettier. So yeah, huge shout out to them.
Good.
Well, thanks everybody. I really appreciate you all coming and engaging with us and thinking deeply about multiplication. And I hope that you have some fun this week multiplying with your students and maybe considering the Egyptians and base 2. All right. Well, have a great week and we'll see you next week for division.
Thanks.